Hello, this is a robots video. I thought I would talk to you about robots and robotics, and I've provided a document in the description for you to have a look at the English of this video, what I'm trying to explain, so it gives you a better understanding of this video and robotics in general. So robotics is a branch of technology that includes how to design a robot, the construction of a robot, how it operates, how to manufacture it. In other words, how to make a large production of a certain robot, and the application of the robot. In other words, what jobs are required by the robot considering its environment, and if there are other robots to work with. There are classifications of robots by environment and mechanism of interaction. So what is specified by what type of job that the robot needs to do. So classifications. So one of them is collaborative robots. These are robots that are built to work together with other robots that function on enormous assembly lines, like for example in car factories. Another classification is in the operating room. Surgeons need steady hands when they are doing a surgical procedure on a patient. They only need to nick an artery or sever something, a piece of tissue that they shouldn't have done. This could be a fatal accident. Another classification: law enforcement and emergency response situations. So for example, a bomb disposal robot can be designed to assess threats and include a variety of sensors and remote monitoring tools to assess the situation and to make perhaps a bomb safe if there is a threat of a terrorist attack. Robot can also be used in an emergency situation, like in a burning building, or to see if there's any burning people or anyone injured inside the building. They can also assess the condition of a building that has had a fire or that's been in an earthquake. Another classification: welding with robots. Like surgeons, welders must be incredibly accurate with their movements. Welding robots are used in the construction of ships, cars, and planes, and they can become very useful in construction, and robot engineers have to develop tailored welding systems for each field, considering ease of use as a key factor. Another application is agriculture or on the farm. Farmers have to deal with a different variety of weather conditions, soil conditions, maybe dealing with pests, and obviously the labour is quite difficult. So farming equipment has become much more sophisticated and needs to be more now autonomous to navigate plants, weeds, harvest certain crops. Also, milking machines for dairy are just the beginning of robotics applications for livestock, for milking the cow. Additional robots handle duties like weed control, plant nursing and feeding, pollution monitoring, and even planting of seeding new crops. There has been a high demand for these kinds of robots to pick and move fruit, partly because of the labour shortages and how hard it is sometimes for a person to go long hours, and under specific weather conditions it is better for a robot to deal with. Another application of a robot can also be in the construction site, where builders are building a new house or block of flats. And robots have been known to build brick houses 4 times as fast as a human worker. It combines a 3D printer and a robot that can lay bricks just as precisely as human workers. Also, applications such as demolition, transport, surveying, and infrastructure inspection. Developers are integrating robots with other devices such as drones to further increase their usability. Imagine drones that can be used to transport materials, or better yet, ones that can build solid architectural structures. Okay, so even though these applications are quite specific and quite unique, there are certain shared goals and component technologies for developers to keep in mind. For example, in surgery, welding and construction, robots need to relieve humans of the cognitive and the physical difficulties while improving the precision and the reliability of the job. Obviously, there are high risks to some of these jobs. Now, what is hard for a human is easy for a robot, like repetitive tasks, continuous operation like working for long periods of time. Also can do complicated calculations, deal with huge databases of information. Also dangerous and risky tasks like construction. So another thing, what is easy for a human is also difficult sometimes for a robot, like reasoning, adapting to new situations, flexible to changing requirements, integrating multiple sensors and working all at the same time, resolving conflicting data, resolving and synthesizing unrelated information, being also creative. So the history of robotics and robots was introduced in 1941 with a scientist called Issac Asimov, who published a science fiction short story called Liar in the May issue magazine called Astounded Science Fiction. He first introduced the 3 laws of robotics. A robot may not injure a human being or through inaction allowing a human being to come to harm. This is the first law. The second law, a robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. The third law is a robot must protect its own existence as long as such protection does not conflict with the first or the second law. So the word robots, where does it come from? Firstly, it was introduced in a play in 1920 called The Rossum's Universal Robots. The English phrase Rossum's Universal Robots has been used as a subtitle. It premiered on the 25th of January in 1921 and introduced the word robot to the English language and to science fiction as a whole. In 1954, a man called George Devol invented the first digitally operated and a programmable robot called the Unimate. In 1956, Devol and his partner Joseph Engelberger formed the world's first robot company. In 1961, the first industrial robot, Unimate, went online in a General Motors automobile factory in New Jersey. Automobile is basically cars, a car factory. So I hope you enjoyed this video on the introduction of robots, and there will be more videos to come. Check out the document in the description for a few activities about this video. Take care. Bye for now.